Okay, I'm just going to start by running through the transformations of a function just to make sure you're happy and you know what they all are, because I think you're overthinking this question. Okay, if you've got a function y equals f of x, say, there are various transformations you can do. Now, the first one is if you add a constant, okay, and the effect of the adding a constant moves it up the y-axis. So it moves the whole function through the vector 0, a. So you just think you're picking up that function and moving it, say, 3 up or 5 up. Obviously, if it's negative, you're moving it down. The next one you've got is if you add something to the x value within the function, okay? The effect of this is moving it left a. So you imagine you're moving it through the vector minus a naught. You're moving it left by a. If it were a minus a, it would therefore move the function to the right. Okay, the other things we could do to our y as f of x is we could multiply it by a constant. Now we can either multiply the outcome by a constant, by putting a constant right in front of a function there. Now the effect this would have, I want you to imagine you've got a graph. Imagine it was fixed all along the y-axis. It was glued there. And you took hold of the graph either side and stretched it that way and that way by scale factor a. Okay? So that's the effect of multiplying a by f of x. We've also got, what if you multiply your x value by a constant? Again, a similar scenario. I want you to imagine there's your function there, but this time it's glued down the y-axis, and you grab it on either side and push it in. So you're kind of effectively multiplying it by scale factor 1 over a. You're shrinking it, okay? It's compacting it together. The final two transformations you've got are if you had y equals minus f of x. Now, the effect of this is it reflects the graph in the x-axis. Okay, so you literally do a reflection in the x-axis, and y equals f of minus x, and that's a reflection in the y-axis. Okay, let's look at the first question you asked me about. We've got this function, y equals 2 f of x plus 3. Now, you mentioned completing the square. When you're asked to transform functions, don't worry about trying to do anything algebraic. Think about what has happened to the function. It's pictorial. Okay, so I think you're overthinking it by completing the square. Let's have a look at what's happened to this f of x. And think about the order of operations. Do you remember BIDMAS from GCSE? So, here's our function f of x. Now the first thing that's happened to it is the whole function has been multiplied by 2. Now if you remember, multiplying the whole function by 2 means it's a stretch parallel to the y-axis. So this graph has been glued to the x-axis. We imagine it's glued along this line, and then we've taken the graph and stretched all the points out. So the 0 stays there and the 4 stays there. But this minus 2 minus 4, it's got twice as far away from the x-axis. It's still at minus 2, but now it's at minus 8. So that's the first step. And we're following the order of operations, okay? So it was first multiplied by 2. The next step is this graph has been shifted. We've added 3 to the function 2f of x. Now the effect of adding 3 is to move it through the vector 0, 3. So move it up 3 places. I'm going to redraw it because I don't want to draw it on the same graph. So I'm looking at my red graph, my stretched graph, so I've done that bit. Now I'm going to move it 3 up. So my 0 point, where it crosses the y-axis, will now cross at the point 3. This point here, this 4 point, will become somewhere up here. slightly irrelevant, it's just sitting on my graph. This point here, the x coordinate won't change, but the y coordinate will go up 3. So that will become -2, -5. And there's my new function. Okay, let's look at part 4. We've got the function is a transformation again, and this time it's y equals f of 2x plus 3. Well, the first thing that's happened, thinking about BIDMAS, is we've multiplied the x value by 2. Now, if you remember, this is again a stretch, but it's about the y-axis. We imagine our graph is stuck. Any points here are stuck. So that point 0, 0 is stuck. Everything else is multiplied by scale factor a half because it's inverse. It's 1/2. So we halve all the other y values. So this 4 comes into the point 2. So it now crosses at 2. This -2 becomes -1. So our low point is at -1. The y value is not affected because it's been squashed this way. Okay, so we've got the coordinate there of our minimum is -1, -4. So that's the first transformation that's taken place, this squash. Okay, let's look at the second transformation. Oh, it's +3 again. So it's been shifted 3 up the y-axis, so through the vector 0, 3. Again, I'm going to draw it on a separate set of axes because I think it's too hard to draw 2 transformations on one. So I'm looking at this red graph now. Now it's been shifted up 3, so let's think about where it's been moved to. So this point, this intersection with the y has gone up 3, so it's here. This point here has moved up 3, well, it's sort of somewhere up here, slightly irrelevant, we don't know where it is. This point here, that's still at -4, sorry, has moved up 3 again, so it's now at -1. The x value hasn't changed, but the y value has to -1. So there it is. There's our function. Okay, here's the final one. Y equals 3 lots of f of x minus 2. Okay, we're thinking about Beamer again. What's happened to the x value first? Well, it's had 2 subtracted from it. Magically appeared graph there. Forgot to draw. Okay, so it's had 2 subtracted from the x value. Now, the effect of this, remember, the effect of subtracting something from the x value within the brackets is actually to move it right 2. It goes the other way. Okay, so let's draw that new graph on then. So the -4 coordinate will become -2. The 0 coordinate will become 2. And our minimum here will happen at 0, -4. So we've effectively added 2 to each of the x coordinates. Okay, that's our first step. Right, let's think about our second step. Now it's then had this stretch. Now the stretch is scale factor 3. It's of the whole function, outside the whole function, which means we glue it to that x-axis. We imagine it's glued there. So those points are going to stay. So we know our graph is stuck on the points -2 and 2, and we stretch it either side. So it's going to get steeper either side, and it's by scale factor 3. So 3 times, it's still at 0, the x coordinate, but the y coordinate will be 3 times -4, which is -12.